Okay, I've got a couple of questions I got one question from 3.2, number 66 in the book. And our numbers, I can't remember which one it is. Hold on a second and I'll tell you which one it is online. It's number 66 in the book, number 13 online. And I went ahead and I worked the problem out because I had so much to show you between the calculator and everything. I didn't want to go all over the place, so I figured I would just go ahead and work everything out for this one. First of all, whenever you have a projectile, okay, whenever you have a projectile and it's going up and down, usually it's going to fall in this type of equation, okay? It's going to be negative 16t squared plus the speed, the initial velocity, v sub o, plus the y-intercept, which is going to be your height. Okay? So whenever you have any kind of trajectory, as the old saying goes, what goes up must come down. See? Like that. And that's negative 16t squared plus blah, 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 plus blah, blah, blah. All right? Now, once you get this in the calculator, punch this in the calculator, you're going to get all of this. And then you can hit second trace and find whatever you need. You need to find your vertex, which is right here. Second trace, give a left area, give a right area, and then a guess, and then let the calculator find it. The second thing you can do is when you find, or after you do that, you can put y, or you got y sub 1 is equal to, in the graph, negative 16t squared plus 214t plus 103, and put y sub 2 in your graph, set it equal to 418, because that's what they're asking you right there. When y is 418 feet, and for a parabola, what goes up, it gets 418 feet goes up, it goes past 418 feet, then it goes up to 818, and then it starts to come back down, and it goes back to 418, and then back to 0. That's where it hits the ground. Because sometimes they will ask you, how many seconds does it take to hit the ground? Well, this don't count because this is in the building, and that don't count. So this right here would be your seconds, right here. So you just got to find your x-intercept. You do that with trace, find the 0 with second trace. Now, pull up the result from your graph, and you'll see where they cross. I have to switch it to mouse. This is so aggravating sometimes. There. And you see the 418 feet hits right here and right here. And you go to second trace, and I'm going to find the intercept. And there, okay, it's asking, okay, you want us to intersect the first curve, which is the parabola. Yes, enter. With the second curve, which is the line. Yes. And the guess, I'm going to put it right about there. Enter. And at 1.68 seconds, 1.68 seconds, it is at 418 feet. So let's go to the other 418 feet. So second, calculate, or second trace. Well, you got to get out of this, sorry. Oh, me. Second, quit. Second, quit. Okay, it's not. Now let's try it. Okay, now I can't get to the second, quit. There we go. And second, trace. And I want to find the intersection. of first line, which is negative 16x squared. And second curve, yes, and put the guess now. Hold on a minute. For some reason, this thing is going haywire. There. So the guess is, please, right in there. Really? Oh my Lord. I don't know what's going on with this thing. It won't stop. Second, quit. Okay. Second, off. Okay, the calculator has gone haywire, so I can't do anything, but if you find that second point, it's going to be over here, or you can set it equal to 418 feet, and you say 418 and solve, and it'll give you this point right here. So I don't know what's going on with the calculator. I guess it's just going to keep going until it blows up eventually, yeah. And yes, I've tried to cut this off, and yes, it doesn't work. I don't know why this is red. I've never seen it red before. And it won't cut off. Just keeps on going. Did it stop? Graph. Zoom. Standard. Yeah, it's not. It's locking itself down. I can't turn it off. Okay. Alrighty, that takes care of that calculator. Might as well just exit out of that. Okay, it may ask you about when does it hit the ground, and it hits the ground, you find your 0 over here. Okay, let's get to another problem because that calculator's shot and I can't do anything on that one. Alright, next thing. Let me erase this so everybody can see. Next thing is 4.111, the first question. Okay? So let's look, see what it says. And it says, okay, we're talking about domain of radicals, and okay, I'll just make this a lesson. All right, before I told you that domain is usually all real numbers unless it is affected by a radical. Domain is affected by anything that has a radical or a rational. Okay, I've said it several times before in Unit 1 and Unit 2, or Unit 1 and Unit 2. If I give you f of x is equal to x squared, that's not a radical or a rational, and you can put anything in there. And that's what domain is. Domain is what can I put in this formula as far as a number? What can I put in it? You can put anything you want to in x squared. You can put a negative 1/2, you can put a 2, you can put a 100, you can put a 1/2, you can put anything you want to in it. All right? What about f of x is equal to x cubed? Yeah. Put anything in there. It's only restricted by the instructions or the instructor. In other words, if I say you can only use -2 to +2, then you can't use 4. But if there's no restriction, the domain usually on all these, unless restricted by the instruction or the instructor, usually it's going to be all real numbers, negative infinity to positive infinity. But when you have a radical, f of x is equal to the square root of x plus 3. Or you have a rational. Then you're going to have a problem with the domain. Okay? This is where you have a problem with the domain if, so how do you know what to do? Well, you've got to set the radicand, or this is called the radicand, or the denominator equal to 0. Because 0, you can't have a negative when this is even. When this is a 2 or a 4 or a 6 or an 8 or a 10, you can't have the even root of a negative number. So anything below 0 is negative. And I'll show you that in just a minute. You can't have a 0 in the denominator. That gives you what we call a vertical asymptote. Okay? Vertical asymptote is a part of the graph that the function converges on but never touches or crosses. All right, so let me go to another screen and I'll show you what I'm talking about. And you use these two examples to kind of help you with other examples. Let's say I give you f of x is equal to the square root of x plus 2. Well, the first thing I do is say, okay, x plus 2 is equal to 0. X is equal to negative 2. Now, what happens when I put negative 2 into that equation? Well, f of x, or f of negative 2, sorry, gotta be perfect on this. F of negative 2, when I plug that in, will give me the square root of 0, which is 0. You can take the square root of 0. But what happens when I plug in negative 3? Because you're using negative 2 as a benchmark. This is what we call a benchmark. Something that you use as kind of a status, okay? If I plug in negative 2, that's going to give me a 0. Well, what if I plug in negative 3? Well, if I plug in negative 3, because this is a benchmark, okay? If I plug in negative 3, I'm going to get square root of negative 1, which I can't do. But what if I go above the benchmark? F of negative 1. And that's going to give me a negative 1, that'll give me a positive 1, which I can do. So I can do these. So from the benchmark up, I can do. Benchmark down, I can't do. So you need to write that. Okay, let's do that as a number line. You don't have to, but it's easier for people to see. 0, negative 1, positive 1, 2, and negative 2. Oh, sorry. Shoot. Let me erase this. Negative 3 and positive 3. And then positive infinity and negative infinity. All right, so I'm going to shade what we just did. Okay, I can use negative 2 and I can use negative 1. I can use negative 2 and I can use negative 1, 0, yeah, everything above it. So my domain starts at negative 2 and goes to positive infinity. Always parenthesis goes on and then a bracket here because I can use negative 2. So that's my domain. Okay. Range is usually not asked of these, but the range would be, well, what does negative 2 give you? Negative 2, when you plugged it in, gave you a what? A 0. So your range on the y-axis is going to be from 0 to infinity. So that's your range. Usually it's asked on the graph. It's not asked algebraically. Okay? Now that's with a radical. All right? So, and let's look at the... Okay, this is attached to the x, so that's a horizontal shift of 2 to the left. So the regular family of graph of square root symbol looks like that. All right, so you're going to move it 2 to the left, 1, 2. All that stuff that you learned in Unit 1 and Unit 2. So there's the graph right there. So Read the domain. Well, it starts at -2 and it goes to what? Infinity. Positive infinity. Where's the range? Well, the range starts at 0 and goes what? To infinity, because that keeps on going. So we are correct with the square root. Now remember, it has to be an even root. The square root, which is nothing there, is assumed to be a square. The fourth root, the sixth root, the eighth root, and so on. Now, what about the third root? Well, you can plug it in. You can plug in a negative and a positive with the third root. So it really doesn't matter with the third root, fifth root. It doesn't matter because the domain is going to be all real numbers unless the instructor or the instructions tell you to restrict the domain. Okay? So really, all you have to worry about is radicals and rationals. Radicals with an even index. All right? So that's a radical. All right, what about a rational? A rational, that's like this problem right here. A rational number, a rational number, I can't have x, I can't have 0 in the x-intercept, in the denominator. So here, x cannot equal 0. So your domain is from negative infinity to 0. I can't use 0. And then from 0 to infinity. And I can't use 0, so it gets a parenthesis. The reason I can't use 0 is if you plug 0 into this function, it's going to blow up. It's going to give you an undefined function. Now, these two are not overlapping. So not overlapping is a union. So that's a union. If it overlaps, it's a intersection. So that's your domain. Okay? Now, as I showed you in Unit 1, the family of graphs, what does 1 over x look like? It looks like half a volcano. Okay? Now, I don't mean to sound repetitive, but I don't show you the things in Unit 1 so you can forget them after Unit 1 tests. You are in college algebra. From here on out, from college algebra to college trig to Calc 1 to Calc 2 to Calc 3, you're building onto what you just took. All right? So if you're one of these people that take Unit 1 test and just forget about it, well, you're going to have problems with Unit 2 and Unit 3 because everything that you build on with Unit 1 and Unit 2 is going to be in the Unit 3 test. Everything in the Unit 1, Unit 2, Unit 3 is going to be on the Unit 4 test. So it's cumulative. You can't get away from it after college algebra. All right? This is in your Unit 1 or Unit 2. I showed you the family of graphs. And this is f of x is equal to 1 over x. Look at it. Here is this is what's called a vertical asymptote. That's what we just said right here. This is x cannot equal 0. Okay? I just made that red. I can't touch it. See, it's converging right here. This function is converging onto this red line, but it's not touching it. This function up here, which is the same function, is converging onto this red line, but it's not touching it. It never will touch it. That's what converging means. It means it gets closer and closer, but never touches. That's called a vertical asymptote. When you set the denominator, or the radicand, when you set them equal to 0, you are finding the vertical asymptote, if I spell it right. Okay? That is very important for one of these sections coming up, or it might be this section, I don't know. All right? When you set the denominator or the radicand equal to 0, you are finding the vertical asymptote. How do you find the horizontal asymptote? Well, there is a test for the horizontal asymptote, and it's in your book. I don't know which page it's on, but there's 3 tests for the horizontal asymptote. Okay, the horizontal asymptote depends on the degree of the numerator and the denominator. Okay, this is x of 0. This is x of 1. So if the degree of the denominator, so I'm going to put degree of the denominator, I'm going to put degree of denominator is higher than the degree of the numerator, then your vertical asymptote, your horizontal asymptote is going to be 0. Okay? If they are equal, if the degree of the numerator is equal to, I'm just going to say the degree of the dn is equal to the degree of the numerator, then you use that coefficient. Okay? And this test, there's 3 tests. There's 1, 2, and 3 is long division. Okay? If the degree of the numerator or denominator is less than the degree of the numerator, then you use long division, and it's either a linear, meaning y is equal to mx plus b. I'm sorry, that would be a oblique. Sorry. Oblique or horizontal. It's oblique if you get y is equal to 2x, y is equal to 4x, y is equal. But if you get y is equal to 2, then it's just a horizontal line. Or y is equal to a number, you get a horizontal line. And that's on one of your pages. That's why you got to look at the book, or it's in the notes. I put it in the notes. So to find the vertical asymptote, you set denominator equal to what? 0. That's to find the vertical asymptote. To find the horizontal asymptote, use the test right here, which I want you to find it either in the videos or the book. It'll be, I think, in blue. It'll be one of those boxes that are shaded in blue or yellow, and it'll have that list. It'll say horizontal asymptote. Okay, so the domain is from negative infinity to, boom, 0. And then does not touch 0, and then it starts back and goes to positive infinity. That's the domain of this function. The range, negative infinity, boop, to 0, does not touch 0, then goes to positive infinity. And that's the way you do it with radicals and rationals. That is how you do radicals and rationals. Okay, let's look at the next question. Which is probably like this one. Please work with me. All right, the next one. 4.129/12. Okay, again, this is the same stuff that you used in Unit 1 and Unit 2. Like I said, you've got to be able to look at this stuff. Remember when I showed you f of x is equal to a times x plus k, x plus h, quantity squared, plus k. And I think in the videos I do absolute value also. F of x is equal to a absolute value of x plus h plus k. And I think I might do 1 or 2 more. And I highlight. I go, okay, what does this show us? And I highlight the A. That gives us orientation compared to the basic model. Basic model comes from the videos. What does H do? That's the horizontal what? The horizontal shift. If it's negative, it goes to the right. If it's positive, it goes to the what? Left. The K, what is K? That's your vertical shift. Vertical means positive, it goes up, negative, it goes down. So let's look at this one. This one is f of x is equal to 1 over x minus 6 quantity squared plus 0. Okay, this is a rational function. It follows the same thing. This is a right here. So let's look. Take my handy dandy highlighter. I'm going to highlight A. A is 1. I'm sorry. A is 1. So that means it's a basic model. What basic model of what? Well, look at your family of graphs. Which ones does this look like? Looks like 1 over x. F of x is equal to 1 over x. See? F of x is equal to 1 over, and there's an x down there. All right? Now, it's 1 over x squared, and I got one of those 2 in the family of graphs. Remember, 1 over x looks like this. 1 over x squared looks like what? The volcano. So you know that this function is going to look like that. So that's the basic model, because this is 1. Technically 1 over 1, which is 1. So this is the basic model. So you know that all 4 of these graphs look like a volcano. So you're good. All right, now let's look at the horizontal shift. Horizontal shift is yellow. It's inside the parentheses. There it is. That means a positive shift to the right of 6 places. Okay, now as you're watching this video, you should be saying to yourself, oh, I see what he's doing now. He's putting this with the stuff in Unit 1 and 2. Yes, that's what you should be seeing. You should be seeing that this is the horizontal shift. Okay? 6 to the right. 6 to the right. Well, that's not, I'm sorry. Yeah, 6 to the right. Well, that's not it, because it moves 6 to the left. That's not it. This moves 6 up. That's not it. This moves 6 down. That's not it. So the only one it can be is this one, because of this right here, 6 to the right. Okay? What's the domain of this function? We'll look at it. Here's your vertical asymptote right here. So it doesn't touch that number, which is 6, because this tells you the horizontal shift. Okay? So, and you can set that equal to 6. 6 minus 6 is 0. So 6 is you cannot use 6 in this function. Set this equal to 0. X minus 6 is equal to 0. X cannot equal 6. If you put 6 into this function, it'll blow it up, so you can't use it. So negative infinity to 6. I can't touch 6, but I can keep going after 6. So negative infinity to 6, parenthesis, and then it's a union, 6 to infinity. The range starts at 0 and goes to infinity. So the range is from 0 to infinity. And you don't touch 0 either. So that's the domain and the range. Okay? And what they're telling you right here, right there, is they saying, go back to Unit 1 and look at the family of graphs. That's what they're telling you to do. Okay? Next question. I just don't want people in college algebra, I don't want anybody thinking that, okay, we're starting Unit 3. That means we're starting over. No, you're continuing Unit 1 and Unit 2. That's exactly what you're doing. Okay? Hold on, I gotta switch back to the mouse. There we go. Next one. 4.15/3. I probably covered this already, but yeah. Okay, so this one looks like a half a volcano. Look on your family of graphs. This is 1 over x. F of x is equal to 1 over x. It looks like 1 over x plus 0. Okay? So that means that I've got 1 over x plus 0 plus 0. That's what it looks like. All right? Now, this graph on your family of graphs looks like this. That's what it looks like. So now I know what the graph looks like. It looks like that. Looks like the one in green. But this number right here is the horizontal shift, which means 3 to the right. And this means a vertical shift of 1 up. So now this point right there is now this point right here. I wish I could move that up, but I can't. All I can do is do this. I can do this and it may work, I don't know. Please work with me. Yeah, right there. I can move it right there, but, and let me put a black line. Really? I'm sorry, just bear with me. Let me put a black line right here. Let's see. There. Okay, so what I did is I took the old graph, which was right here, and I moved it 3 to the right, based on that, 3 to the right, and 1 what? Up. And that's it. Okay, now, what is the vertical asymptote? The vertical asymptote is 3. X is equal to 3. Okay? And I think 1 is your horizontal asymptote because it's not touching 1. So the domain and range here would be of the green. Let me go back to green. Negative infinity to what? Negative infinity to 3. And then from 3 to what? Positive infinity. Okay, that's your domain. Range is from negative infinity to 1. And then from 1 to what? Positive infinity. That's how you do it. Again, all this comes from Unit 1 and Unit 2. Hopefully, doing these 3 questions, you're probably saying to yourself, "Oh, I see what's going on now," and that's good. That's a good thing. Let's look at the last question, and this is 4.2, number 9. 4.2, number 9. 4.2, number 9. Identify vertical, horizontal, or oblique asymptotes in the graph over here on the right. Okay, well, I'm going to blow it up. Okay, all right. The line is the blue line, okay? Let me put down f of x is equal to what's in blue. So that's the function. All right, dashed lines are always asymptotes. All right, always. See, the blue line gets right up next to the dashed line, but it never touches it. It converges onto it. So that means that you've got two asymptotes here. All right, you've got this asymptote, which is a vertical asymptote because it's going vertically. So that means x is equal to something. So you've got a vertical asymptote, and that's in yellow. Vertical asymptote. I'm just going to put that. Oh, no, go ahead. And I'm going to say z is equal to, it looks like 1, -1. So I'm sorry, not z. X is equal to -1. That's your vertical asymptote. And your horizontal asymptote would be going in this direction, but that's not the case. We don't have a horizontal asymptote. So that means that this is an oblique asymptote. And I'm going to color that in green. An oblique asymptote is one that goes in a diagonal direction, whether it goes up or down. There's your oblique asymptote. An oblique asymptote is going to follow the y is equal to mx plus b. So we need to find the y-intercept. Is 1, 2, 3. There's the y-intercept. And what is the slope? 1 goes 1, 2, 3 over 1, so 3x, and it's a negative slope, so it's negative 3x plus 3, something like that. So there is your oblique asymptote, and here is your vertical asymptote. So we got a vertical asymptote and a horizontal asymptote. If it asks, there they are. There's the, and then you know that from your, doing stuff back in graphing days, where you graph lines. Okay? And I think that's probably what they're going to be asking. What is the domain of that function? Well, the domain is going to be from negative infinity to that vertical asymptote, which is negative 1 or whatever. And then from where it crosses that, or from negative 1, negative infinity to negative 1, and then from negative 1 to positive infinity, which I think that's what this is. Yep. Now the range is going to be all real numbers, because those lines just keep going up and down, and you don't have a vertical asymptote, a horizontal asymptote. So that should be your answer there. Okay. I hope that helps. That was all the questions I saw today. So hope that helps.